Hello, and welcome to Mr. Winzinger's World of Education, where today we present aerodynamics. Just how does an airplane stay in the air, and what are the parts on an airplane that allow it to function? Let's take a look. We'll start with lift. Lift is a primary reason that an aircraft can stay in the air. As you can see from the cutaway view of a wing, it is shaped in what is called an airfoil. This is a side view, or a cutaway view of the wing, and it's what's known as an airfoil. The top of the wing is longer than the bottom of the wing, as you can see from the shape. As air rushes over the wing, it has to travel a longer distance over the top than it does over the bottom. And as the air moves across the wing, both on the top and the bottom, it does so in the same amount of time. Air starts here, goes over the bottom, and over the top. This creates low pressure, or a lifting effect, on the top of the wing, and high pressure, or a pushing effect, over the bottom of the wing. Push, pull. Push, pull. Low pressure, high pressure. So, like pushing on a board, the wing goes up into the air. This scientific principle is known as the Bernoulli effect, and it is why an airplane flies. And on our lower diagram, we have a different view, which focuses on the air going over and under the wing. And as you can see, the air over the wing has to travel a greater distance than the air under the wing. Of course, the airfoil is curved on top and pretty much flat on the bottom. Now, let's take a look at the parts of an airplane that allow it to function. Here we have a picture of an airplane. This would be your basic propeller-driven Cessna 152. And as you can see, it's color-coded, so we can explain all the different parts on the aircraft. First, let's look at the aileron. That's in green. This is what makes the airplane turn or bank, roll, left and right. And we have a little model here of a World War II aircraft called the Hellcat. It was a very effective aircraft in World War II. So what does the aileron do? It allows the aircraft to bank or roll left and right, left and right. The next part that we'll take a look at are the flaps. Flaps are in yellow. They're positioned on the inboard side of the aircraft wing, and the flaps will extend downward at different degrees, 10, 20, 30, 45, in order to allow the aircraft to have more lift at lower speeds. Basically, it takes the shape of the wing, and we'll show you that again, and changes it. So the flap down here extended, we'll draw a little picture. You see that the shape of the wing would change, making it longer and allowing it to create more lift at lower speed. And back to our aircraft picture. Next, we'll take a look at the vertical stabilizer, which is in purple. This is what makes the airplane yaw or pivot side to side when the rudder is used. We'll explain the rudder in a moment. It's attached to the vertical stabilizer. Back to our picture or model. And here is your vertical stabilizer with the rudder attached to the back. When the rudder is not being used and is positioned straight or flush with the vertical stabilizer, it allows the aircraft to fly in a straight line. Next, the rudder, which again is attached to the vertical stabilizer. This is what makes the aircraft yaw or pitch or move, actually, in this way. This is called a yaw. So if you're flying along and you move the rudder to the left or the right, it will cause the airplane to move like this. Or if you're flying sideways, like it would cause the aircraft to, again, yaw. Just like that. Next, let's take a look at the horizontal stabilizer. This is the horizontal stabilizer, which is part of the tail section. The horizontal stabilizer is right here. When the elevators, which are attached to the back and move up and down, when they are flush with the horizontal stabilizer, it allows the aircraft to move in a straight line. Now the elevator, in green, in the same way the rudder moves left and right, oops, don't want to lose that, to give an aircraft yaw, the elevator attached to the end of the horizontal stabilizer allows the aircraft to pitch up and down. So the rudder gives us yaw, yaw, and the elevator gives us pitch down so the aircraft can descend in altitude, up so that the aircraft can climb. Of course, you don't want to go into an excessive pitch situation, because then the air over the wing will be disturbed and you'll lose lift, which will cause the aircraft to abruptly descend. So you have to be careful. And lift all depends on airspeed. So anyway, we've talked about the ailerons, which give roll, the rudder, which allows the aircraft to yaw, looking at it this way, and the elevator, which controls pitch. And there we have our three axes of flight: roll, yaw, and pitch. And that allows our aircraft to move or to fly in three directions. Climb, descend, turn, and so forth. Next, we'll take a look at the propeller. This was the early mode of propulsion used by the Wright brothers in order to move the aircraft forward. Of course, you can have a jet which pushes, a jet engine, or sometimes the propeller is positioned in the back of the airplane to push. On this type of aircraft, it's in front so that it pulls. By moving the aircraft through the air, we get the flow of air over the wing. And of course, once the speed gets great enough, the pressure differential is great enough so that the airplane flies. At a certain speed, say 100 miles an hour, maybe a smaller aircraft, 80 miles an hour, or knots, which is the measurement used in flight, the airfoil will begin to function because the pressure differential now allows the lift process to take place. We don't want to lose our airplane picture here. Now we'll go ahead and finish up by looking at the other basic parts of the airplane. The engine, which would be underneath this cowling, kind of like a hood on an automobile, would be positioned with this type of aircraft behind the propeller. Obviously, the engine makes the propeller turn. The fuselage is in red, and it is the body of the aircraft, which contains the pilot, passengers, and of course any cargo. Landing gear is always very important so that you can roll the aircraft on the ground during takeoff and landing. On this particular aircraft, it's fixed, meaning the landing gear is always extended even while flying. But on all modern jetliners and other more expensive aircraft, the landing gear will retract into and out of the fuselage of the aircraft. Fuel is usually kept in the wing. On the inside of the wing, there's a lot of empty space to fill up the fuel tank at certain entry points. And usually the fuel tanks are separated. You might have 1, 2, 3 different fuel tanks or more in the aircraft. Of course, when flying the aircraft, you need to be able to talk to people, the tower at the airport, or en route to air traffic control. So you'll need a radio, and you'll find a radio antenna here in green on every aircraft. At night, you want other aircraft and people at the airport to see you, so you'll have navigation lights on the wing and a beacon on the tail. The beacon usually flashes. It's white so that aircraft flying in the air with you can see you at night and you can avoid a collision. Navigation lights